homework help video class. Let's go ahead and get started with this video. Students, numbers 1 through 9, the directions say to find the inverse and then verify it by using composition. So let's start off with this function right here, okay? Let's first of all find the inverse. I've taught you how to do that. We have y equals 6x. So where the y is, we're going to put an x. And where the x is, we're going to put a y, okay? Now we're going to get y by itself, divide both sides by 6, and we get 1/6 x equals y. So f of x equals 6x. F inverse, please don't say f negative 1, it's pronounced f inverse of x, equals 1/6 x. Where this y is right here, I just put f inverse of x. So there, just like that, I found my inverse function. Now let's verify it. Let's find f of f inverse of x. So start with your f function, 6x. Where the x is, we're going to put a big parentheses. And inside that, we're going to put 1/6 x. 6 times 1/6 is 1. So we get 1x, or x. Now we're going to find f inverse of f of x. So we're going to start with our f inverse function, which is 1/6 x. Where the x is, we'll put a big parentheses, and inside that we're going to put 6x. Alright, now 1/6 times 6 over 1 is going to give you 1x, or x. So we're good. Moving on to number 3. Alright, let's find the inverse of this function. We have y equals x plus 9. Where the y is, I'll put an x. Where the x is, I'll put a y. Now solve for y, bring the 9 over and make it a negative 9. And there is your inverse function. So f inverse. And I'm getting really tired of putting f inverse. So I'm just going to use g of x for my inverse function. So my inverse function is x minus 9. Okay? Alright, and so let's quickly take the composition going both directions. F of g of x. Alright, take your f function, x plus 9. Where the x is, we're going to put a big parentheses. Plus 9. Next is g, so pick up g and put it right here. X minus 9 plus 9 is x. Now we're going to find the composition f of, or g of f of x. So I start with my g function. Where the x is, I'm going to put a big parentheses. And then inside that parentheses, my next function is f. So I'm going to pick up f right here and put it right here. X plus 9 minus 9 is x. So it checks. Alright, number 5. Alright, let's find the inverse of this function. Y equals 3x plus 1. In order to find an inverse, we swap the x's and y's. Where the y's are, you put an x. And where the x's are, you put y's. Now we're going to solve for y. Bring your 1 over and make it a negative 1. And then divide everything by 3. So 1/3 x minus 1/3 equals y. So our inverse function, we're going to call our inverse functions g of x is 1/3 x minus 1/3. So here we go. Let's take our composition here. Let's verify that we have inverse functions. F of g of x. Where the f function is, here's my f function. Where the x is, I put a big parentheses, and then plus 1. Then pick up the g and put it right here. 1/3 x minus 1/3. Now take your 3 and multiply it through. 3 times 1/3 is 1x. 3 times negative 1/3 is negative 1. Plus 1. Your 1's cancel out, leaving you with x. Now we're going to find g of f of x. Alright, so here we go. Take your g function, which is this here, and where the x is, you're going to put a really big parentheses. Now, in place of that parentheses, you're going to put your f function, which is 3x plus 1. Now take your 1/3 and multiply it through. So 1/3 times 3 is 1. 1x. 1/3 times 1 is 1/3. And then bring down your negative 1/3. These will cancel, leaving you with x. Checks. Alright, moving on to number 7. Let's see. Where the y is, I'm going to put an x, and where the x is, I'm going to put a y. Now, to get y by itself, the first thing we want to do is get rid of our fraction. So I'm going to multiply both sides by 5. The reason I chose 5 is because 5 is my denominator in my fraction. So 5 times x is 5x. And if you multiply this fraction by 5, your 5's would cancel, leaving you with y minus 1. Now simply bring the 1 over and make it positive. 5x plus 1 equals y. So my inverse function, I'm going to call it g of x, equals 5x plus 1. Alright. So here we go. Let's confirm that we truly have inverse functions by f of g of x and g of f of x. Alright, take your f function where the x is, put a big parentheses. Now pick up your g function and put it in the parentheses. Alright, 5x plus 1 minus 1 leaves you with 5x up top. 5 in the denominator. Your 5's cancel, leaving you with x. Over here we'll take our g function, and where the x is we'll put a big parentheses. And then in that parentheses we're going to put our f function, which is x minus 1 over 5. Now remember, this 5 right here is really over 1. So 5 over 1 times x minus 1 over 5. Your 5's would cancel, leaving you with x minus 1 plus 1, which is x. Checks. Okay. Alright, number 9. Okay, let's go ahead and find the inverse function. Y equals the cubed root of x. Now, everywhere there's a y, we're going to put an x. And everywhere there's an x, we're going to put a y. Okay? There we go. Now, in order to get y by itself, you need to get rid of this cubed root. In order to get rid of a cubed root, you have to cube both sides. So if you cube this side, you just get x cubed. If you cube a cubed root like this, you just get the radicand on the inside. So there we go. Y's all by itself. So my inverse function is g of x equals x cubed. Alright, let's go ahead and use composition of functions to confirm that we truly have inverse functions. Alright, here we go. Take my f function, which is this, and everywhere there's an x, we're going to put a big parentheses. Alright. Now we're going to pick this up and put it inside the parentheses. And the cubed root of x cubed is x. Now, take your g function. Everywhere there's an x, we're going to put a big parentheses. And now we're going to pick up this function here, your f function, and put it right here. So we have a cubed root raised to a third power. Well, if you cube a cubed root, you're left with the inside, which is x. So yes, it checks. Alright, okay, moving on now to numbers 11 through 21. When I gave this assignment, I told you guys, first of all, don't worry about graphing them, and secondly, you're going to prove that these are inverses by simply doing f of g of x and g of f of x very quickly, okay? So let's start off first of all with f of g of x, alright? A lot of redundancy here, but good practice. Okay, here's your f function. Where the x is, you put a parentheses. Now pick up your g and put it over here. 2 over 1. 2 over 1 times x over 2. Your 2's cancel, leaving you with x. Now let's find g of f of x. Alright, here we go. Take your g function. Where there's an x, you put a big parentheses. Now pick up your f function and put it right here. 2x over 2. Your 2's cancel, leaving you with x. Alright, number 13. Let's start with f of g of x. So take your f function, and where the parentheses is, or where the x is, we're going to put a parentheses. Then bring your g function over and put it here in the parentheses. Alright, remember your 5 is over 1. 5 over 1 times x minus 1 over 5. These would cancel right here. And you're left with x minus 1 plus 1, which is x. Now g of f of x. Okay, we'll take your g function, and where the x is, we're going to put parentheses. Then we'll pick up the f function and put it over here. 5x plus 1, okay? Well, for the numerator, 5x plus 1 minus 1 is just 5x. And then your 5's cancel, leaving you with x. So it checks. Alright, number 15. Let's start off here with f of g of x. Take your f function, put a big parentheses and put a 3. Then pick this up and put it right over here. Whenever inside, which is x. Now over here we're going to do g of f of x. So take your g function. Everywhere there's an x, we're going to put a big parentheses. And then we're going to pick up this function over here and put it in the parentheses. Whenever you have the cube root of something cubed, you get just the base. So we're left with x. The cube root of x cubed is x. So it checks. Number 17. Alright, let's take our f function, and everywhere there's an x, I'm going to put a parentheses. Then I'm going to pick up my g function and put it right over here. So here we go. X squared plus 4 minus 4 leaves me with x squared. And the square root of x squared is x. Alright, now take your g function. Everywhere there's an x, we'll put a parentheses. And now pick up your f function and put it here in the parentheses. Remember, students, whenever you square a square root, you're left over with the radicand, so x minus 4. And then bring down your positive 4. And you're left with x. Okay? Number 19. Alright, let's see what we have here. Here's my f function. So 9 minus, here's my x, put a parentheses. Then pick up your g function and put it right here. 9 square root of 9 minus x. Whenever you square a square root, you're left with what's on the inside, so 9 minus x. And then we have 9 minus 9 minus x would be 9 minus 9 plus x. This negative makes this negative makes this positive. 9 minus 9 cancels. You're left with x. Now, let's do g of f of x. So take your g function, and everywhere there's an x, we're going to put a parentheses. Now pick up your f function and put it right in here. 9 minus x squared. Alright, now, watch your signs carefully. We have 9 minus 9 minus a negative x squared. And of course 9 minus 9 cancels out, leaving you with the square root of x squared, which is x. Okay, so it checks. Alright, moving on to number 21. Now this one here is going to be really not hard. It's going to be a pain, and it's going to be long, and I hope I don't make a little mistake and have to start over, okay? But here we go. Let's see if we can't do this, okay? Alright, now. Okay, let's do f of g of x. So take your f function. Everywhere there's an x, put a parentheses. Now pick up your g function and put it inside the parentheses. So negative 5x plus 1 over x minus 1. Negative 5x plus 1 over x minus 1. Now, let's pause and think how we can simplify this. First of all, you could get a common denominator for this 1 right here. And then subtract the two fractions. That's not a bad idea, but to be honest with you. And then down here, the same thing. But I really feel like, excuse me for yawning, I really feel like I've got a better idea. I feel like, remember guys, anytime you have a fraction like 3/7, you can multiply the top by, I don't know, 9, as long as you also multiply the bottom by what? 9. Okay? So you can multiply a fraction by anything, as long as you do it to the top and bottom. Well, it's the same thing here. I can multiply this fraction by anything, as long as I do it to the top and bottom. So here's what I'm thinking. I notice both my denominators are x minus 1, here and here. See that? So watch this. If I multiply the top of this fraction times x minus 1, and the bottom of the fraction times x minus 1, let's kind of see what happens, okay? So I'm going to multiply the top and the bottom by x minus 1. So I'm going to take this whole numerator and multiply it by what? X minus 1 over 1. So here we go. First of all, I've got to multiply it times this term, and then multiply it times this term. I have two terms, this term and this term, okay? It's kind of like having a number on the outside of a parentheses, and you've got to take that number and multiply it through both terms. In fact, I said it's kind of like that. It's exactly like that, okay? It's the same principle and everything. So here we go. If I take a negative times a positive, a negative fraction times a positive, I'm left with a negative, alright? And it would be x minus 1 would cancel with your x minus 1, leaving you a negative 5x plus 1, and that negative does go to the whole expression, so I put parentheses around it. Now, negative 1 times x minus 1 would be, now watch your signs, guys, it'd be a negative x minus 1. You do need the parentheses. This negative 1 gets multiplied times the x and the negative 1 both. So see how helpful that was, guys? Look how much that simplified the numerator. All of my fractions are gone. So now let's multiply the denominator down here by the same thing, x minus 1 over 1. Okay, well, your x minus 1 cancels with your x minus 1, so you're left with a negative 5x plus 1. And then plus 5, okay? So positive 5, x minus 1. Now, let's go ahead and simplify our numerator. Take this negative sign and multiply it through. That gives you negative 5x, negative 1. Now take this negative sign and multiply it through. That gives you a negative x and a positive 1. Now come down here, take your negative sign and multiply it through. So negative 5x, negative 1. Okay? Take your 5 and multiply it through, and you get a positive 5x and a negative 5. Okay? Now, don't, please, students, don't start doing this. Cancel, cancel. No, you cannot do that. That is totally incorrect, okay? Because you have more than one term in the numerator or the denominator. Look, anytime you have more than one term in the top or the bottom, either one, you can't just start canceling. Now we can simplify the top. Look, negative 1, positive 1, negative 1 cancels with this. Negative 5x, negative 1x. That's negative 6x. Now, negative 5x, positive 5x, they cancel out. Negative 1, negative 5 is a negative 6, and look at that, okay? This cancels here, leaving you with x. So students, that was f of g of x. I really feel like, it's going to be the same thing all over again over here, and I really am not being lazy. I just don't feel like doing that again. I guess really though, I should, so okay, that's fine. So f of g of x gave you an x. So now g of f of x, going very quickly. Let's see what happens. Take your g function. You have a negative sign here out front, and then we're going to put 5 parentheses, put a big parentheses, then plus 1, and then put a parentheses for the bottom, and then minus 1, okay? Right here we're going to put x minus 1 over x plus 5, and then right here we're going to put x minus 1 over x plus 5, okay? Now, my denominators here are x plus 5, so I'm going to multiply this whole numerator here by x plus 5 over 1. I'm going to multiply this whole denominator by x plus 5 over 1. So here we go. Are you ready? Alright. This would cancel with this. Well, first of all, this negative sign out front, we got to bring that right over here and put it here. Okay? Now, x plus 5 times x plus 5, they would cancel, leaving you with 5 parentheses x minus 1. Okay, do you see that? This would cancel with this, leaving you with 5 times x minus 1. Okay? Now, 1 times x plus 5 is just going to be positive x plus 5. Now, down to the numerator, we have this times this. So your x plus 5 would cancel, leaving you with x minus 1. So I have x minus 1. Then here, negative 1 times x plus 5 would be negative 1 parentheses x plus 5. Now, let's simplify the numerator. Put your negative sign right here. 5 times x is 5x. 5 times negative 1 is negative 5. Bring down your positive x. Bring down your positive 5. In the denominator, we have a negative 1 being multiplied through. So x minus 1, negative 1 times x is negative x. Negative 1 times 5 is negative 5. So next, put a negative sign here. And then let's see what we got. 5x plus x is 6x. Your positive 5 and negative 5 cancel out. Your x's cancel out. and a negative 1, and a negative 5 is a negative 6. So you have a negative sign, bring that down, and then you're left over with a negative x, because these 6's cancel, leaving you with a negative 1. X over negative 1 is negative x, but you have a negative sign here, so negative negative does give you a positive x. So there we go, moving on. Okay, now in 23, the directions say, does this function have an inverse function? Now please listen to me carefully. Please listen to me so carefully, students. If this question would have said, now listen to me, does this table of values represent a function, then you would say, do all of my inputs, do all of my x's have one output? Okay? But it's not what it says. It says, does this table of values have an inverse function? So we have to go backwards. We have to look at the y values and see if they give us any two values out, and they do. Look at negative 2. Negative 2 gives me a negative 1, and negative 2 also gives me a what? 3. So negative 2 gives me a negative 1, and it gives me a 3. Now I know that's the opposite of what you're used to, but remember, we're not looking at this and saying, is it a function? We're looking at it and saying, does it have an inverse function? So we have to do it backwards, okay? So the answer is no, it does not have an inverse function, because there were some values here that gave us two different values out. Alright, moving on to number 25. Does the function have an inverse function? Now remember, if I said to you, is this graph a function? You would use the vertical line test, but that's not what they're asking. They're asking, does this graph have an inverse function? So you use the horizontal line test, and I don't care how many horizontal lines you draw, everyone's going to cross the graph only once. So yes, the horizontal line test passes. This function here, this graph, does have an inverse function. Yes, it does. Okay, number 26, vertical line test. Guys, I know it kind of looks like it's narrowing out there, or it's kind of leveling out, but it's not. It's slowly but surely getting higher, but it really doesn't matter, because right here, if you draw a vertical line there, it obviously intersects the graph in more than one place. So no, this graph does not pass the horizontal line test. So no, this graph does not have an inverse function. It does not. Alright, number 20, number 29. The directions say to use the graphing utility to graph the function and then use the horizontal line test. Okay, so let me grab my grapher. I'm going to give you guys a little advice on how to type this in. Go to your y equals button, obviously, and clear out your equations there. I would type parentheses 4 minus x, close your parentheses. Now, the reason you should do that is you want the calculator to know that the entire numerator is 4 minus x. Then hit divided by, and then hit 6, and then hit graph. Let's see if our window's good enough. It looks pretty good to me, guys. I'm getting a slanted line that goes down like this. So the horizontal line test would pass. No matter where you draw that horizontal line, it's only going to cross the graph once. So yes, this function does have an inverse function. Alright, remember how to use absolute values. In case you've forgotten, let me refresh your memory, okay? The first thing you want to do is get an absolute value right here. So I want you to go to your y equals button and hit enter. That's top left button. And when you do, it pops off your equations. I would clear out the one you just had in there. And now I would hit math and then go over 1 to numbers. So push math, and when you push the math button, you're going to have 4 words going across the top: math, numbers, CPX, and PRB. Go over to numbers, and notice option number 1 is ABS. That's absolute values. So hit enter on it, and then type in x plus 4. And when you hit enter on that, on your y equals, it should say ABS parentheses. Now type x plus 4, and then just close the parentheses. That's all you got to do. Just close the parentheses. Alright. Then hit minus sign. Minus. And now you need another absolute value, so hit math, and then scroll over to numbers. Then go down to option 1, hit enter, and it should say ABS again with the parentheses. You type in x minus 4, and then close the parentheses. And let me hit enter on this, or graph. Let me hit graph, and we'll see what sometimes you see a curve like this on a graph, and even though it looks like it's leveling off, it's always gradually getting higher and higher. That is not the case on number 31. Now, I should have my answer key open. I don't, so let me quickly bend over here and take a look at the book and see, but I'm 99.9% sure this is constant right here. This is constant right here, and this is constant, which means it's a completely horizontal line. And if that's the case, guys, then the horizontal line test fails, because if you draw horizontal lines here, everything looks great. But if you draw a horizontal line right here, it's going to hit this graph over and over and over an infinite amount of times. But let me pause the video and pull up the back of the book and see. So yes, students, I was actually right for once in my life. So the horizontal line test does fail, and so the answer is no. This function does not have an inverse function. All right, number 33. Well, let's go ahead and hit y equals, and then clear out the equation you had in there, and type in -2 and then x. That's easy enough. So -2x. Then hit your square root button. So this pops up like that. And then type in 16 minus x squared, and then close your parentheses. Like that. Now hit graph, and let's see what we get. Okay, it looks like I'm getting this on a standard window. I'm getting this, then it disappears, then comes down again like this, and then disappears, then comes back up. So I've got to increase my y window up and my y window down. So go to your y, go to your window, find the window button, push window, and I'm going to make my y minimum like -20 and my y maximum 20, and now hit graph. Let's see, that totally took care of it. Okay, so the graph looks like this. Well, obviously the horizontal line test is going to fail here, 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 here. So it only takes one line to make the horizontal line test fail. So the horizontal line test does fail. So no, this function does not have an inverse function. It does not. Okay, moving on to numbers 35 through, let me see here, 35 through 49. And these are the ones I told you to use your grapher. We first are going to find the inverse function and then graph it on the same coordinate axis. Okay, so let's go through this hopefully pretty quickly, and we'll see how we do. Okay, step one, they want us to find the inverse function. Okay, so here we go. We have y equals 2x minus 3. Everywhere there's a y, I'm going to put an x. Everywhere there's an x, I'm going to put a y. Now we're going to solve for y. Bring the 3 over and make it positive. Now divide everything by 2. 1/2 x plus 3/2 equals y. Okay, so here's your inverse function right here. So what they want us to do now with our graphers is they want us to go to y equals and put both these equations in. So hit y equals and add y subscript 1. Y subscript 1, you're going to type in 2x minus 3, then hit enter. And that's going to jump you down to the next line. And then for y subscript 2, you're going to type in 0.5x plus 1.5. It's easier to put decimals in because this is 0.5 and 3 over 2 is 1.5. Now hit graph, and you're going to see inverse graphs. It's very cool, okay? You're going to see one line on your screen go like this. And you see the other line go something like this. And if you were to graph the y equals x line, just trust me, all the points on this are going to be the complete opposite of all the points on the other line, okay? Alright, moving on to 37. Alright, students, here we go. Let's find the inverse of this function. Y equals x to the 5th minus 2. Where the y is, I'll put an x. Where the x is, I'll put a y. And let's solve for y. Bring the 2 over and make it positive. And now take the 5th root of both sides. So the 5th root of x plus 2 equals the fifth root of y to the fifth is y. So there we go. Alright, so let's go ahead and type both these into our calculators. Let's go with y. Hit your y equals button and clear out the two equations that were just in there. And now let's type in x to the fifth, so x arrow 5 minus 2. So it should look like this. You would want to type x arrow 5, then minus 2. That's your y subscript 1. Then hit enter for your y subscript 2. Now listen carefully how you type it a fifth root. Please listen to me carefully. First of all, trust me, hit the number 5. Push 5, okay? Then hit math. Then scroll down to option 5. Option 5 has an x with the square root, and since you've put a 5 there already, go ahead and scroll down to option 5 and hit enter. When you do, this appears on your screen, and what that tells the computer is this 5 goes right here for the x. So now you have fifth root of x plus 2. And put parentheses around that. I should have told you that. I forgot to say that. Put parentheses x plus 2 and close your parentheses. You want the computer to know that entire thing is under the radical. Then hit graph, and you're going to see two graphs that are truly inverses of each other. Alright? And there they are. That's perfect, guys. I mean, I'm telling you, every point that's on the one line, we got to go to the table of values and look. Okay? And, well, they're giving you some pretty, let's see here. Okay, if you'll go to your table of values if you want to, and you got an x column, and then a y subscript 1, then a y subscript 2. Just to pick out one point, if you'll look at negative 1, you'll see that you get a negative 3 here. So for the first function, when you put in negative 1, you got out negative 3. That means for the other function, you should put in a negative 3 and get out negative 1. So look, find negative 3 in this column, and then go way over to here, and you'll see there's a negative 1 there. Okay, this is working just fine. Alright, number 39. Okay, here we go. So here's y equals the square root of x. Where the y is, I'll put an x. Where the x is, I'll put a y. Now you have a square root you want to get rid of, so square both sides. Square the x. Square this side and you get y. So there's your function. Y equals x squared. So here we go. Let's type in this first function here. Y equals, clear out your two equations. And equation number 1, you're going to hit square root of x and close the parentheses. Then hit enter. And for your second equation, you're simply going to hit x and then squared and then graph. And I think it'd be very beneficial if you would, I'm going to go ahead and change my window back to 6, a standard window, and that'll help a little bit, okay? So there we go. Now the only problem I see is, no, it's fine, guys, actually it's fine. For 39, I'm trying to see if they give you a domain. They really don't, that's fine. This is totally, I'm not going to get into the nitpicky things. This is totally fine. Alright, number 41, okay? Well, here's my y. Y equals the square root of 4 minus x squared. Now, where the y is, I'm going to put an x, and where the x is, I'm going to put a y. I'm not worried about the domain. They were just simply saying, because this is a square root, they're just saying that only certain numbers can go into the radical. That's all they're saying, okay? Alright, now, let's see here. We're going to solve for y. So to get rid of the square root, we're going to square both sides. When you square x, you get x squared. When you square the radical, you get 4 minus y squared. Now bring the 4 over and make it negative. Now change all the signs so your y squared is positive. And now take the square root of both sides, okay? Now students, I paused the video to see if the back of the book had a plus minus. I didn't think they should, and they don't, and let me explain to you why. Now, I know it's a little frustrating sometimes, Mr. Earhart. You told us if you choose to put the radical in, you put plus minus. I understand that. The problem is you want to have an inverse function, okay? And if you put a plus minus, it is going to give you a graph that would then not be a function. Okay, just trust me, it'd be something like this, something that would not work. So, that's the main reason we're not going to put that. And if you want to put this in a test and a quiz, fine, I'm not going to lose a lot of sleep over it. It's not a big deal. But this is the function you want to use right here, okay? So let's go ahead and plot, or let's go ahead and type both of these into our calculator, okay? And let's see what happens here. So here we go. Alright. Let me grab my calculator here and go to y equals, clear out both of my equations, and for my first one here, I'm going to type in, I'm going to hit the square root, and so this pops up with the parentheses, so square root, and then 4 minus x squared, so 4 minus x squared, and then close the parentheses, and then hit enter, and now you're down to the second line, and now type this in, so second square root, and this will pop up, and then type negative x squared plus 4, and then close the parentheses. And guys, then hit graph, and we should be good, okay? Now students, if you'll look at your graph, you're going to see a really small semicircle like this. I want to encourage you to change your x window to go to your window and make your x values run from -4 to +4, and then hit graph. And you're going to see that thing stretched out a little more. But the problem is that's the only graph that I'm seeing is this stretched out semicircle. Is it possible for two functions that are inverses of each other to fall on top of each other? Yes, it is. Let me give you a hypothetical situation. We're going to call this function here f. We're going to call this function over here f inverse. Now, if this ordered pair right here exists on this graph, what has to exist over here? We learned this the other day. 4, 2, we learned that, okay? However, what if on this graph over here, 4, 2 exists? That's possible. Well, if it exists here, then what has to exist over here? 2, 4. And what if that continues on and on through both functions? Then what you get is a 2, 4 over here, and a 2, 4 over here, and a 4, 2 over here, and a 4, 2 over here. So is it theoretically possible? Well, not just theoretically. Is it definitely possible for inverse functions to fall right on top of each other? Yes, it is. Most definitely it is. Okay? It is. In very rare situations. Alright, number 43. Alright, let's go ahead and find the inverse of this function. So where's my y? Right here. And everywhere there's a y, I'm going to go ahead and put an x. And everywhere there's an x, I'm going to go ahead and put a y. Now, I'm going to multiply the entire equation by y minus 2 over 1. So y minus 2 times x would be x, y minus 2x, okay? X times y, x times -2. Over here, your x minus 2 would cancel, and you're left with y plus 1. Now, if you're trying to solve for y, which we are, you want to get y by itself. So, here's a y term, and here's a y term. Get them both on the same side. So bring your y over and make it a negative y. See this -2x? Get rid of it. Bring it over to the other side. So now I have 1 plus 2x. Now why did I get all of the y terms on one side? So I can factor out my y. Pull out a y and you're left with x minus 1. Let's see if that's right. Y times x is xy. Y times -1 is -y. That's totally correct. Now divide both sides by x minus 1, and you have the inverse function. 1 plus 2x divided by x minus 1. So we're going to type this into our calculator. So let me go ahead and get my graph up up here and go to y equals, clear out both functions. I'm going to type in x plus 1 in parentheses. Make sure it's in parentheses, it'll look like this. Type in x plus 1, close the parentheses, then division, then parentheses x minus 2. That's exactly what it should look like. So hit your y equals, put a parentheses, x plus 1, close your parentheses, divided by x minus 2. Be sure and put that in parentheses, then hit enter, and now you're down to the second line. Be sure and put parentheses, 1 plus 2x, close the parentheses, divided by, and then x minus 1 in parentheses. So here we go, parentheses, 1 plus 2x. Close the parentheses, and then divided by x minus 1 in parentheses. And then hit graph, and let's see what we get. I think it's going to help to go back to our standard window. So I'm going to hit zoom 6. And it looks like yep, there it is. We get a graph that, I'm going to do it real small here, that comes across like this. We get a graph that comes across and then zooms down. And then we get one up top here that's kind of doing the same thing. Actually, I'm going to need a lot more room than this. I should have taken pictures of these, guys. I didn't think of that till right now, but that's okay. Yeah, this is really pretty cool. It's hard. I'm going to get rid of the axes. I can't tell where they're at, but you're going to get one graph that comes down and goes like this. And then you're going to get one that comes like this and goes like this. And then up top here, you're going to have the same thing. You're going to have one that goes like this, and then one that starts here and goes like this. And that's perfect. That's exactly what it should look like. The inverse graphs. Okay, number 47. Where the y is, right here, I'm going to put an x in just a minute. And where the x is, I'm going to put a y. Okay, to get rid of this cubed root, I'm going to raise both sides to the third power. So I'm going to cube this side and cube this side. So I get x cubed equals cube a cubed root. You get y minus 1. Bring the 1 over and make it positive. So x cubed plus 1 equals y. Okay, so there is my inverse function. So very quickly, I'm going to go to my y equals and clear out my two equations. I'm going to type this one in first. Now cubed root, guys, go to math and look down at the fourth option. You'll see a cubed root. So hit that, and then this will pop up. Cubed root of x, then type in x minus 1 like that. So x minus 1, close the parentheses, and then hit enter. And now you're down to y subscript 2. Alright, so now we're going to type in x cubed, so x arrow 3x cubed, and then plus 1. And then hit graph. And let's see what you get. Looks like you get one graph that comes across and snakes up like this. Then you get one that comes along and hits right here, and then goes like that and continues on, something like that, okay? So there it is, guys. And those two graphs are inverses of each other. Number 49. Okay, here's my y, f of x. I'm going to put an x. Here's my x. I'm going to put a y. 6y plus 4. Here's another x. I'm going to put a y. 4y plus 5. Now, I'm going to multiply the entire equation by the denominator, which is 4y plus 5 over 1. So over here I would have 4x y plus 5x. X times this whole group. Over here on the right side, these will cancel, leave me with 6y plus 4. Now we did one just like this a couple problems ago. We want to get all the y terms on one side. So here's 4xy, bring the 6y over and make it negative. Bring the 5x over here, and it becomes 4 minus 5x. Now, factor out a y here, and you pull out a y, you're left with 4x minus 6, okay? equals 4 minus 5x. And then divide both sides by this parentheses here. So y equals 4 minus 5x divided by 4x minus 6. Okay, so there's your inverse function. Not too difficult. Let's go ahead and type both of these in and see if we can get the graphs up here. Okay, students, I'm back. My computer, this program sometimes crashes, and I was able to save the video, but not what was written here. So I was able to go over here and cut and paste it. Yeah, there it is. Good, I was able to save it. Okay, so this is what I got, guys, for my inverse function, okay? 4 minus 5x and 4x minus 6, okay? So let's go ahead and type these into our calculators. Let me go ahead and set my calculator down here. Let's hit y equals and clear out your two equations that were there. Let me get a drink here real quick. And then we'll go ahead and continue on now. For your top, 4 minus 5x. Be sure and put parentheses around that parentheses. 4 minus 5x. Then close your parentheses. Then divided by, well, you know what, I'm sorry. Let's start all over. I'm going to type this one in first, right over here. Okay, so parentheses 6x plus 4, close the parentheses, divided by parentheses 4x plus 5. Okay, then hit enter, go down to the next line, your y, subscript 2, hit parentheses, then 4 minus 5x, close your parentheses, divided by, then parentheses 4x minus 6, close your parentheses, then hit graph, and let's kind of see what happens here, okay? Yep, looks really good. You're getting a curve. Yep, I'm not going to try to draw this, but you're definitely getting, well, I'll show you one. You're getting one graph. I can get my pen to work here. You're getting one graph that comes up like this to the left and shoots up. And the graph that reflects that is one over here that does this. Okay, and then there's another graph that comes right along here, if you'll look, and shoots up like that. And the one that's an inverse of that comes right along here and crosses and then goes down like that. That's pretty much what you should be getting, okay? Alright, moving on to number 51. The directions for 51 through 63 say determine whether the function has an inverse function. If it does, then find the inverse function. Now, here's how I've taught you guys to do this. If you have a graph, you use the horizontal line graph, the horizontal line test. If you don't, you do it a little differently. Now listen to me. If I ask you, does this equation represent y as a function of x, then you get y by itself. But that's not what I'm asking you. I'm asking you, does this function have an inverse? So you get x by itself, okay? So I have y equal x to the fourth. Take the fourth root of both sides, and when you do, you gotta put plus minus. Get x by itself, and now you do everything backwards, because I'm not asking you, does this equation represent a function? I'm asking you, does this function have an inverse function? So everything's backwards. Instead of solving for y, we're solving for x. Instead of putting values in for x, we're putting values in for y. If I put a value in for y, will I get one output? Or will I get more than one output? Well, I'm going to get more than one output. If I put 16 in here, the fourth root of 16 is 2. So if I put 16 in, I'm getting out positive 2, and I'm also getting out negative 2 because the plus minus. So no, this equation does not have an inverse function. No, because this input here gives you two outputs. Now I know it's confusing to call y an input, but we're doing everything backwards on these. Alright, number 53. Okay, I'm going to get x by itself, so I'm going to multiply both sides by 8. Okay, this is really my y. Multiply both sides by 8. 8y equals x. Now, is every number you put in for y, are you going to get out just one output? Yes, you are. I don't care what you put in for y. You will always get out one output. So every input for y is one output. So yes, this function definitely has an inverse function. Definitely. Alright, number 55. Alright, y equals negative 4. Okay? Now I'm going to go ahead and put plus 0x, just so that helps you a little bit, okay, if you're a little confused on this. And to be honest with you guys, a problem like this I was getting ready to put a 0x in and do it that way, but that's really, I'm trying to think if that's the best way to do this. Let's see. That's really not the best way to do it because you can't really solve for x because 0x doesn't exist. 0x is 0. So when you cannot solve for x like I've taught you to, let's get a picture of this thing. A picture always helps. P of x is y, y equals -4. So if you were to graph this, you would have a horizontal line going through -4. Right here, the black line is the graph right here. So there's your horizontal line going through -4 right there. Okay, now there's the graph of this function here. Now that I have a graph of it, now that I have a graph of this equation, forget the equation, let's use the graph. Let's use the horizontal line test. Well, Mr. Earhart, why are you not using the vertical line test? Because the vertical line test is used when I'm asking you, is this a function? I'm not asking you if this is a function. I'm asking you, does this graph have an inverse function? Well, the horizontal line test fails. I mean, if you draw a horizontal line right here, it's going to intersect this graph infinite times. So the horizontal line test fails. So the answer is no. This graph, this equation that we just had up here, this function right here, right there it is here, does not have an inverse function. Does not. Alright, number 57. Alright, let's go ahead and get x by itself if we can. Now, we might not be able to, okay? And if we can't, that's okay. We're just going to try to. Alright. Let's see, we have y equals x plus 3 squared. Now, what I'm going to do is I'm going to take the square root of both sides. So if I take the square root of y, that's going to be plus minus. If I take the square root of this, I'm left. If I take the square root of x plus 3 squared, anytime you take the square root of something squared, you're left with a base, which is x plus 3. Now bring the 3 over and make it negative. So plus minus square root of y minus 3 equals x. Well, guys, this is obviously not a function, okay? Because look, I know you're used to putting values in for x, but remember on these problems, we're doing everything backwards, okay? So here we're putting values in for y. Now, when you put values in for y, when you're putting values in for y, you're going to get out more than one value. For example, let's say I put 9 in here, okay? If I put a 9 in for y, the square root of 9 is 3. 3 minus 3 is 0. The square root of 9 is 3. There's a negative sign. -3, -3, -3 is -6. So if I put 9 in for y, then I get out 2 outputs, okay? So no, this function here does not have an inverse, okay? Number 59. Alright, now this one here is going to be like number 55. It's going to be really hard to do this without a graph. So I'm just going to graph it super quick, okay? Like in 60 seconds. For this piece up here, I have y equals x plus 3. And x is less than 0. So, table of values, I'm going to put in a 0, -1, -2, because x is less than 0. Now there's no equal sign here, so x really isn't supposed to be 0. So I'm going to circle this to remind me there's a hole in the graph. Put a 0 in, get a 3, put a -1 in, get out a 2, put a -2 in, get out a 1. So 0, 3 is a hole. -1, 2 is here. And -2, 1 is here. Remember, you always start, whatever your first point is in your table of values, start there and draw the line, okay? So there we go. Now let's quickly graph the other part. Y equals 6 minus x, and your domain is x is greater than or equal to 0. So here we go. We're going to put 0 in for x, then 1, then 2. Put a 0 in, we get a 6. Put a 1 in, we get a 5. Put a 2 in, we get a 4. So 0, 6. 1, 5. 2, 4. Always start with the first ordered pair and go and draw it from there, okay? There we go. Well, students, does the horizontal line test fail? right here. If you draw a horizontal line there, it intersects the graph in more than one place. So no, 59 does not represent a function. Look at 61. They were nice to us. They gave us a graph. The horizontal line test totally passes. I don't care where you draw a horizontal line, as long as you keep it truly horizontal. One horizontal line here is going to fit right in between them. Every horizontal line that you draw will not intersect the graph more than once, okay? So, number 61 does have an inverse function, okay? It does. Now, hold on 1 second. Alright, let's continue on to number 63. Now, okay, here we go. Horizontal line test. Totally passes. Totally passes. So, number 63 does have an inverse function. Yes, it does. Alright, moving on to numbers 65 through 69. And we're going to use these functions here. And I should have copied these down already. If you'll look in the directions, you'll see we have f of x equals 1/8 x minus 3. And g of x equals x cubed. Alright, now, they want us to take the composition of each of these functions, okay? And notice in the parentheses first, we're going to take, not composition, sorry, inverse. We're going to find the inverse of function f, find the inverse of function g, and then find their composition. That's crazy. So here we go. So let's go ahead and find the inverse of this function here. Alright. So here we go. Y equals 1/8 x minus 3. Where the y is, I'll put an x. Where the x is, I'll put a y. Now, bring the 3 over and make it a positive 3. And then multiply everything by 8 to get rid of this fraction. So 8x plus 24 equals 1y, which is y. So there's the inverse of f. Now the inverse of g is going to be y equals x cubed. So where the y is, put an x. Where the x is, put a y. And now get y by itself. So the cubed root of x equals y. Okay? Now we're going to find the composition f inverse of g inverse. So take your f function, which is right here, and if there's an x, we're going to put a big parentheses. So this is your f inverse right here. This is your g inverse right here. Okay? Alright? So everywhere there's an x, put a big parentheses. So x, big parentheses, plus 24. Now pick up your g function and put it in right over here, the cubed root of x. Okay? Now let's simplify. We'd have 8 times the cube root of x plus 24. And now they want us to put what in? 1. Put a 1 in for x. So we have 8 times the cube root of 1 plus 24. Okay? So the cube root of 1 is 1. 1 times 8 is 8. 8 plus 24 is 32. And let me look in the back of the book. That should be right. And yes, it is. Now, I don't want to totally blow you out of the water, but I want to show you something that's really cool, okay? Now, I taught you this in your notes, so really we could have saved a little bit of time, okay? Here's my g inverse right here, okay? Here's my f inverse right here. Got it? Now watch this. Remember I told you guys, anytime you're doing composition of functions, you don't have to actually find the composition if you're dealing with ordered pairs. Here's what I taught you. I taught you to start with your inner well, actually, you know what I'm trying to think. This might not have worked. Hold on 1 second. Okay, I paused the video to make sure this would work. This totally works. This is really cool. I taught you guys in your notes, we went over this lesson, that when it comes to composition of functions, if they're asking you to find a value of your compositions like they are here, they're telling us to take the composition. That's what this little circle here means. Composition of two inverse functions at a given value. I taught you guys this. Remember, you start with your inside function. Your inside function is g. So in your g function, put this 1 in. put the 1 into g. Here's your g function right here. Here's your f function. Put a 1 in, and what do you get out? A 1. Then I told you to go to your outer function, which is f. This is all in your notes. And whatever you got out, you put it right here. So put that in for x into your f function, and you get out 32. And then what I said is your composition would be this number here and this number here. So 1, comma 32. So when you put in 1, what you get out? 32. Now that's a little confusing. I'm probably shooting over your heads a little bit, but it's still cool to understand that I did not have to find the composition of these two inverse functions. Okay, I did not. I could have just done this here and saved a little bit of time, but that's okay. Alright, number 67. Okay, same thing again, guys. Now, I already found f inverse, correct? Let's go back here. Here's f inverse right here. Okay, 8x plus 24 equals y. Now, I'm going to do it the fast way and then the long way. This is f inverse 1, and this is f inverse 1. Now I'm going to write it twice because I'm doing f inverse of f inverse. Now, go to your inner function, which is this one, and put 6 in. So if I put 6 into my inner function here, I get 48 to carry 1. I think it's 72. I did it quickly. Alright, so then whatever I got out, I put that into my outer function, this. So 8 times 72 plus 24. I'm getting 600, okay? Something tells me I'm probably wrong, but I hope I'm right. Nope, that's right. Okay, good. And so then, after I've done that, I look at my first number and my last number, and that means for my composition, I would have 600. And so 6 gives me out 600. Now, that's the fast way to do it, but it can be confusing, so if you don't like that, that's okay. Let's do it the old-fashioned way. F inverse is right here. F inverse is right here. We're finding F inverse. F inverse of F inverse. So start with your inner function, and where the x is, put a big parentheses. Okay, then pick up this and put it in the parentheses. Now simplify. 8 times 8 is 64. 8 times 24 would be 32. Carry your 3, 192. And then plus 24. Add those two together, you'll get 64x plus 6, 1, carry your 1, 216. Now, trust me, if you put 8 in for x, no, if you put 6, if you put 6 in for x right here, if you put 64 times 6 plus 216, you will get out 600, okay? You will get out 600. So, alright, moving on to number 69. Now, they want us to find the composition first, guys. Find the composition first, and then find the inverse of that function. So, I think I already erased the original functions. I did. That's unfortunate. Okay, so I'm going to find the composition of f, and f is what? 1/8. Let me turn back in my book here. Number 69. 1/8 x minus 3. And g of x is x cubed, I believe, yes. Okay, so very quickly, we're going to find f of g of x. So start with your f function, your outer function. Where the x is, we're going to put a parentheses. And then we're going to pick this up and put it in place here. X cubed. So now I have 1/8 x cubed minus 3. That's the composition. Now, they want us to then take this to the -1, or in other words, they want us to find the inverse function of that. So I'm going to set it equal to y. And now let's find the inverse of this. So where the y is, put an x. And where the x is, put a y. Now get y by itself, bring the 3 over and make it positive. So x plus 3 equals 1/8 y cubed. Next, multiply everything by 8 to get rid of your fraction. So 8x plus 24 equals y cubed. And now take the cubed root of both sides. So the cubed root of 8x plus 24 equals y. Why did I not put plus minus here? Because my index was odd. If your index is odd, you do not put plus minus. And now let me quickly look in the back of the book, and hopefully we're in the general ballpark of being correct. Yes, all that they did was they factored out an 8 inside. Let me show you what they did, guys. Inside the radical, they factored out an 8. So they have this x plus 3, okay? They factored out an 8. Then they took the cube root of 8, so cross off the 8 and put a 2 on the outside. That's totally fine. This is also fine down here. I have no problem with either one. Alright, number 71. Let's take a look at our two functions here that they have for us. F of x is x plus 4. And g of x is 2x minus 5. Now they want us to find the inverse of g and the inverse of f. So let's find g inverse first of all. I have y equals 2x minus 5. Where the y is, I'll put an x, and where the x is, I'll put a y. Solve for y, bring the 5 over and make it positive, and divide everything by 2. So 1 half x plus 5 halves equals y. Now instead of putting y right here, I'm going to go ahead and put it equals g inverse of x. Okay, I took my g function, I got the inverse. Now take your f function, okay, and I've got y equals x plus 4. Where the y is, I'll put an x, and where the x is, I'll put a y. Bring the 4 over, make it negative. X minus 4 equals y. But instead of putting y there, I'm going to put f inverse, okay? So there's the f inverse. So I took my f function, found the inverse, took my g function, found the inverse. Got it? Okay. Now they want us to take the composition of those two functions. See that circle right there? This little circle right here means composition. So they want us to take g inverse. They want us to take g inverse of f inverse. G inverse of f inverse. So we start off with our g function first, and there, everywhere there's an x, we put a parentheses. So 1 half parentheses plus 5 halves. And then we pick up our f inverse and put it over here. So we put x minus 4. 1 half times x is 1 half x. 1 half times 4 is negative 2 plus 5 over 2. Alright, well, use a calculator if you want to, if you're not good with your fractions. Negative 2 plus 5.5 is 2. 5 over 2 is 2.5. So negative 2 plus 2.5 would be a positive 1 half. So there we go. There's the answer. Let me check the back of the book, but that should be pretty accurate, if not exactly right. And, yes, they wrote theirs as one big fraction. They said 1 half x is the same thing as x over 2 plus 1 over 2, which is fine. I mean, 1 half x is x over 2. Then they put the top together, x plus 1 all over 2. That's fine. This is totally fine too, no problem. Alright, number 73. Let me go back and grab these functions here and take those with us. Okay, they first want us to find the composition of these two functions. And then after we find the composition, then find the inverse. This means inverse. So f of g of x. So take your f function, x plus 4, and where the x is, put a big parentheses. Then pick up your g function and put it in over here. So we have 2x minus 5 plus 4 would be negative 1 minus 5 plus 4. So there's your composition. So we found our composition, and now they want us to find the inverse of that. Well, let's set it equal to y, and let's find the inverse, okay? Everywhere there's an x, I'm going to put a y, and everywhere there's a y, I'm going to put an x. Now let's solve for y. 2y equals x plus 1, then divide by 2. Y equals 1 half x plus 1 half. That's the exact same answer we got the last time, and that is correct, okay? Alright, guys, I hope this homework help video has been a help to you. I know it's been pretty long, but it's been a lot of good practice problems. If you have any questions,